Sat Sri Akal students, today I'm there with you to discuss second law of motion. When we talked about first law of motion, students, first law gave us the understanding of inertia. And when we want to talk about second law of motion, it will give us the definition of force. In fact, for a long time, it was understood what is force in terms of just push or pull. But the mankind and the people knowing science could not define force till second law of motion was stated. This was important. The second law of motion is that without understanding, you can never understand that a cricket player, when he tries to catch a very fast coming ball, he, in an instant, as the ball touches his hands, he moves the hands downwards, preventing any injury to his both hands. Why? Number one, why this time gap is there? Why not he catches the ball there only? Number two, the soldiers or police people, when they are in an encounter, uh, they would fire and also receive the shots. They would put their gun in between the sandbags, if you remember. The area from where they shot at the people, they would put the gun in between the sandbags. Why? So when the bullets from the other side hit the sandbags, again, when it will hit, the bullet will move inside a little bit, giving some extra time of impact. That is same as giving some extra time of impact as a cricketer moves quickly, his both hands having ball in it downwards. So the injury is less. Why? So guys, before understanding second law of motion, there are some prerequisites. You must understand these things. Number one, what is rate of? The rate of means very simple. Let's say we have change in velocity. So let's say change in velocity is delta v. That is final velocity v2 minus some initial velocity v1. Right? And what is this delta v? It's basically rate of change of displacement, or maybe distance. Rate of change of distance. So I'll say delta s, rate of change, this is change in distance, divided by t will give me rate of change of distance. That is the definition of velocity. Delta v is change in velocity. If I divide delta t by t, or maybe more accurately delta t, the time interval in which this velocity changes from v1 to v2, making it v2 minus v1. This delta v is change in velocity. Delta v by delta t is rate of change of velocity. Well, that is equal to acceleration, we all know. I'm not going to define acceleration and velocity here. I'm just telling you what is the meaning of rate of. Rate of is something divided by time interval or time. Second, what is momentum? So that's a train moving. It has a lot of momentum. Momentum depends upon two things, mass and velocity. Product of mass and velocity is known as momentum. Guys, this has a lot of relevance in physics. So the unit of momentum is kilogram meter per second, or maybe kilometer per hour. Number three is this sign. This is Sine of Proportionality. If I say x is proportional to y, means when y increases, x will also increase. Or when x decreases, y will also decrease. This is the sign of proportionality. Whenever you have sign of proportionality between two things, and when you want to remove the sign of proportionality and introduce equal to, you have to introduce a constant. Why? Well, the detail can be given later on, or with other videos when you see, you will find the details. Number 4 is impact time. What is impact time? I've very quickly mentioned. Let's say there are two cases. Number one, there is a cement which is dry, and on the other hand, we have a cement which is wet. Now, on the other hand, you have cement after getting wet, after mixing with water, it has got dried up after 3 or 4 days, so it will act really as a stone. Now, guys, uh, imagine a bullet. You're firing a bullet into this sandbag. What will happen? It will go a little bit inside the sandbag, pierce it a little bit, and then possibly if it is very strong, the bullet will come here and it will get reflected, in some angle, hitting somebody else. If it is dry or wet, the bullet, okay, forget about the case when it's dry because density is very less. Let's talk about the uh, cement bag when it is wet. When the bullet strikes, it will go inside the sandbag. It will not get deflected from the surface. Why? Because bullet can penetrate inside. So here the impact time is more. This is a time when two things, they meet each other, in an accident or in a sudden impact. Here impact time is more, here impact time will be less, right? So this is something about impact time. When you have some ball, let's say it strikes the ball strikes and immediately gets deflected in some angle. The impact time, that is time for which the ball and the ball were together, it's very, very less. If you want to increase the impact time, you can make this ball made up of mud that also wet. So the ball, will try to get stuck with this mud wall for some time, increasing the impact time of ball and the ball. Sometimes it'll get stuck there, sometimes it'll get stuck and then again fall back. Could be the case, different cases depending upon the extent to which the mud wall is wet. So this is like impact time. Once you understand all these things, I can define what is second law of motion. Students, second law of motion states, yes, I forgot to tell you, before understanding second law of motion, students, you must also understand what is first law of motion. It's better. The second law of motion states, it gives the definition of force, not just definition of force, it gives a formula to measure the force also. Wonderful formula. The second law of motion states that the rate of change of. So rate of change of. We already know what is rate of change of. Something divided by time. Now, what should be divided by time? Rate of change of momentum. All right. So first we should know change in momentum. And then we'll find rate of change of momentum. Once we know what is change in momentum, it is delta P. The students already delta P by T would be rate of change of momentum. Just like this one was change in distance, rate of change of distance is velocity. Change in velocity, rate of change of velocity is acceleration. This is velocity or maybe speed, depending upon whether the change in direction, a change in distance is unidirectional or multidirectional. Fine. Having defined that, let's see the definition of students' second law of motion once again. It says the second law of motion states that rate of change of momentum. It's the momentum which is important. Of an object, any object, rate of change of momentum of an object is proportional to applied unbalanced force. Okay, applied unbalanced force. And this is unbalanced. Why? Because once the momentum is there, the object is not stationary. Momentum is product of mass and velocity, so it's moving, right? So when it's moving, obviously the force cannot be balanced. When something is in motion, force is not balanced; it is unbalanced. So once again, second law of motion states that rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. So what's this? It says, you know, so many things it says. Number one, it talks about, let's say, this is a, you know, let's say this is a, maybe a rickshaw, or maybe something which is moving, you know there's something which is moving, it has some weight, something is moving, it's not so heavy, means your force, when you apply force, it will affect the force. Let's say something is moving with some velocity, the initial velocity is v1. Okay, now let's say you apply some force f on this for some time t, for some time t seconds, you apply some force. All right. Now this force applied, we want to calculate that how much force we have applied. Initial velocity was v1, and as a result of your application of force in time t, let's say this has moved to this, and the velocity is, final velocity is v2. This all has happened in time t. Fine. So this is one thing. The second thing is, whenever you apply force, you cannot be a magician and say, all right, I apply force and this thing starts getting moving with more velocity. You have to touch it. There comes the concept of impact. Impact is always there when you touch something. So maybe with your hands, maybe with a rod, you push it more. Already it's moving, you push it more, so that in time t, the velocity becomes v2. This is final velocity. This is initial velocity. Now, we want to calculate what is how much force has been applied. That's really interesting. We were not able to find out how much force we applied on this in time t before second law of motion was defined. So it says this, it's very simple. The applied force is basically proportional to the rate of change of momentum. For that, we have to define momentum. Momentum is p, that is product of mass and velocity. Now, what is initial momentum of this body when force was not there? Mass is remaining same, p1. What is final momentum? That is mv2. Having stated, momentum is product of mass and velocity. So what is change in momentum? You see, we can find rate of change of momentum only if we know change in momentum first. So change in momentum is m final momentum minus initial momentum. Very simple. So you could also say this is m into v2 minus v1. Now, this is the change in momentum. And what is rate of change of momentum? That would be delta p by t. So that is equal to m v2 minus v1. I can write delta b divided by t. I've already told you, rate of change of something is you just divide that thing, that quantity by time, you get rate of change. So it says the rate of change of momentum of an object is proportional to applied unbalanced force. That means this unbalanced force which the person has applied on this trolley or something is proportional to rate of change of momentum. And what is rate of change of momentum? M into V2 minus V1 divided by T. Right. So I can say F is proportional to M V2 divided by T minus V1 divided by T. Right? So you can say F is proportional to M into what? Now V2 minus T minus V1 by T, that is basically what? That is, this is change in velocity. You don't take it like this, you just take it like this, only V2 minus V1 by T. This is delta V by T. Change in velocity by time is acceleration, right? Change in velocity by time is acceleration. Acceleration, definition of acceleration is change in velocity divided by time interval. Time interval is T. We have taken initial time as 0. So in time interval, delta T is equal to T2 minus T1 is equal to, now T2 final time is T and initial time is 0. So it is time interval is T1. So that is it. So it says force is proportional to mass into acceleration. Oh, that's really great. Now, if I want to remove sign of proportionality, I have to replace sign of proportionality with equal to. I must introduce some constant k. So it becomes F is equal to kma. Beautiful. Now, students, the unit of force is chosen in such a way that for mass of 1 kg, if acceleration produced is A is 1 meter per second square, I say the force is 1 Newton. In that case, 1 Newton by 1 kilogram by 1 meter per second square, the K becomes 1. I can say F is equal to ma. See guys, you might think in 5 minutes we have derived this formula, but honestly speaking, it has solved major problems of mathematicians and scientists. F is equal to just the product of mass and acceleration. With this, student, we can define what is 1 Newton of force. It says F is m into A. So force is said to be 1 Newton if you apply force on a body having a mass how much? 1 kg. 1 kg body, you apply force and it gets accelerated by 1 meter per second square. Guys, the force can be applied by brakes also. This is the, you know, this is the direction of motion. The force can be applied in opposite direction also. In that case, it would be deceleration. So that will be deceleration of 1 meter per second square. You could take it as negative acceleration also. In any way, force is m into a. Now comes our question that why soldiers use sandbags and why the, you know, the second was the cricketer, when the ball is coming at a large velocity and it suddenly lands into his fist, you could say, you know, if student will take two cases. In one case, this guy is knave and he doesn't move the fist down immediately. So the impact time T is very less. Well, this also reminds me of the technique adopted by some karate masters. If you know, these are the karate masters. They have some bricks here and they have their hand. Now they would strike it, and so that in such a way that the impact time is negligible, very less, very less. Then what will happen? As the T decreases, what happens to force applied? Let's see. As T is very less, T is impact time. Impact time means the uh, time for which the ball, there was an impact of ball in your fist, you know, the time till the hand touched the brick, and then if you see some English movies, they would suddenly take out their hands. They would touch it and suddenly take out their hand. So much force will be applied, all the bricks fall down. Why? See, students, mathematics is a great subject. Mathematics give support to physics and vice versa. We have just seen, according to second law of motion, applied force is proportional to rate of change of momentum, right? Now, momentum is mass into velocity. Rate of change of momentum is m into delta v, that is change in velocity divided by time. See guys, T is impact time. This force applied is inversely proportional to impact time. See guys, if the impact time is more, force applied would be less. And in case the impact time is less, very, very less, very high amount of force would be applied. So next time if you want to slap somebody, what do? You cannot increase muscle power. This is the cheek of a person, this is your hand. You just apply full force and then don't let the hand stay there. Try to decrease your impact time and you will see the person will see definitely starts in the day. Now, this guy, karate master, applies very less time on the bricks. The force is very high. And this person, students, when he puts it down, he actually allows the impact time to be increased.